Hey guys, me again. Trying to make another video here for you to finish up this chapter, solving quadratic systems. So again, one of the reasons I wanted, or the main reason I wanted to hit this right now is there typically is at least one of these on the SAT. So it's a little bit different than what we've been doing as far as, we're not doing a ton of graphing and, find important characteristics. It is kind of a change of pace, but what it is basically solving systems of equations. Now, when you're dealing with quadratic systems, what that basically means is you are dealing with at least one, if not two, of our conic sections. So one of the most important things to kind of understand when you're doing some solving systems like this is whenever you look at a problem like this, you want to look at what are you dealing with? Like what kind of shapes are you dealing with? In this case, because we have one variable squared, we're definitely dealing with a parabola. And then the other one is actually just a line in this case. So when you look at having a parabola and a line, you have a couple different choices as to how it could intersect. You could end up having some sort of parabola and then a line, and then we're looking for two potential solutions. But it doesn't have to be two solutions. It could just be one solution where it's tangent, or you could have it not intersect at all. So it could be no solutions, okay? So when you do a solving systems like this, the first thing I would urge you to do is before you do any actual math, just look at it real quick and decide what are you dealing with. And that's important because you want to know how many solutions are you potentially going to end up with. For that problem, I'm going to do in a second, we do have the potential of two solutions here, but it does not have to be two solutions. It could be one or no solutions, okay? Now, that being said, you could have a conic section with, let's say, a circle and a hyperbola. Well, a circle and a hyperbola, you could have the potential of four solutions that you are trying to find. But it doesn't, again, have to be four solutions. It could be where you have it centered a little bit more like this, and now you have 1, 2, 3, or maybe it right in the middle and it only intersects twice, or maybe it just intersects one of those two parts of the hyperbola, or maybe it doesn't intersect at all. So in that case, we would have the potential of up to 4 possible solutions that we would be on the lookout for. So understanding what shapes you're dealing with gives you a good idea of how many solutions we are potentially looking for, okay? So back to this problem here. We know we are dealing with a parabola, and actually we know that parabola is going right or left just by looking at it because the y is squared. We could do some graphing as far as finding the focus point and all that, but we're not necessarily interested in that right now. We're just trying to find out where these two shapes intersect. So we have a parabola and we have a line. Now, there's a couple different methods of how to solve these, okay? We'll get to those. One kind of a real basic approach. I'm not a huge fan of this approach because I think it's a little bit more time consuming, but some people like it because it's kind of a let the calculator do a lot of the work for you approach, okay? And one method is to use your graphing calculator, and that's to use the graphing function of the graphing calculator. Now, the problem with the graphing calculator is we have to get them to the point where we have it y equals. So the first thing we have to do is we have to take that first equation, that y squared minus 2x minus 10, and we have to get that to where it says y equals. So we can move the 2x and the 10 over, and we get y squared is equal to 2x plus 10. And then we would say we can take the square root of that, which would be 2x, square root of 2x plus 10. But again, anytime we take a square root, we have to account for plus or minus. That's important when we go to use the calculator. Of 2x is right there next to alpha plus 10. But if we press graph right now, that is going to graph half of our parabola. It's not going to graph the whole thing. Okay, so we want the whole thing. So we have to make sure that we put that in one of the y's. In the second y, or another one, we just put the negative version of that same exact thing. So we get negative of 2x plus 10. Okay, so that's how we get the whole conic section. Okay, that's how we get the whole parabola. Now, this one is going to do with blue and red. That's just because I put it in the two different lines, but at least we get the full parabola. And you also want to remember that we put it in as two different lines. So that's going to come into play in just a minute. The next thing we want to do is in the third line is we want to put in the other conic section. Now the other conic section, or the line in this case, is already solved for y, so that one's a little easier to plug in. So we just go negative x minus 1. And then we can graph. Okay. Now, the next step is we got to find the intersection points. We could use the trace feature and kind of get a pretty good estimate, but the problem with the trace feature, number one, it doesn't want to move on me. There it goes. So the problem with the trace feature is it's hard to be really precise, okay? And so I kind of think the answer is -3, looks like 2, but you'll see it's real hard to be precise here, and we want a precise answer. So the calculator does have an intersect feature. Okay, so here's how you do this. It's under the calculate part, which is the blue version or the second version of the trace button. So we hit second, and then the trace button. Okay, the fifth one down is an intersect feature. Okay, now the intersect feature works in a three-step process. So what you do is you want to put the cursor on the first curve. The way you move curves is you just press the up button. So now we go from we're actually on the third curve right now, and then I press up and I go to the second, and then, so you can toggle between the three lines. So the first curve we're going to try to use is the blue line. You put it anywhere on the blue line. Okay. Press enter, and then it asks you, say, what is the second curve that you're trying to find the intersection point of? So the second one we're trying to find the intersection point would be the black one, or the line. And again, you can put it anywhere along that line. It does not matter where you're at. And then it's going to ask you to guess. It's going to say, all right, put the cursor on that as close as you can to get a good estimate there. And then hit enter. And it tells us the actual intersection point is 3, 2. So we have 3, 2. -3, 2 as one of our two answers. And we can do the same thing to find the second intersection point. So we would just go second trace, or hit that calculate, hit that fifth one down. And then now we want to say, what's the first curve? Well, the first curve would probably be the red one now, the bottom part of that parabola. And then we got to make sure we're on the black line somewhere. Yep. And then we guess. And we say, all right, we think the answer is approximately right about there. We press enter, and it tells us the intersection point is +3, -4. Okay. So that is one method of doing this. The problem with this method is, number one, I think it takes a little bit longer. But also, sometimes the answers aren't nice, pretty answers like this one worked out to be. Sometimes they are ugly. And I don't know about you, but when my calculator gives me an ugly answer, sometimes it's a little bit untrustworthy, as far as it's hard to believe that's really the correct answer. So we want some actual formal approaches to do it. I use this method more as a check my answer kind of thing. Make sure I do have the correct answer kind of thing. So another method here. First of all, what are we dealing with? We have x squared plus y squared, so it's plus. We have the same coefficient, so this is a circle. And then we have a line. Okay, so we have a circle and a line. Could have two solutions, could have one solution or no solutions. Okay, so get rid of the calculator for a second. Now, the way I would do this one would actually be the substitution method. Okay, it's the same substitution method that we used when we did solving linear equations back in Algebra 1. So step one, we have to get one of the two equations. I highly recommend that second equation, the minus y or y minus x equals 0. And we just solve that for y or x. It does not really matter. In this case, we know y is equal to x. And then what we can do is we can just say x squared, and we can substitute. We know that y is equal to x, so I can rewrite this as y squared plus, instead of y squared, that y becomes an x squared minus 32 is equal to 0. We have x squared plus x squared, which is 2x squared. And then we can just solve this equation, which gives me 2x squared equals 32. If I move that 32 over, if I divide by 2, I get x squared is equal to 16, which tells me x is equal to plus or minus 4. It's important to remember that plus or minus here because I took a square root of 16. Because I know I'm looking for multiple solutions. That tells me I probably have at least one answer here with the x is 4, and I probably have one where the x is negative 4. Okay? I know I'm not going to get multiple solutions here for each of them because I know I'm dealing with a circle and a line. So now I would just plug each of those probably right into here. So I know y equals x. So whatever x is, y is also the same thing. So the points are 4, 4, and negative 4, negative 4. And again, I could use my graphing calculator to check my solution. I think this method is a lot of times a lot faster. It's definitely a lot more reliable kind of thing. So let's try another one of those. Maybe that one was just a pretty easy one here. So let's try one that looks like this. Now, I've got a positive y squared and a negative x squared. If I flip-flop those, it'd be y squared minus x squared. So this is going to be a hyperbola. And then I have a line. Well, a hyperbola and a line, yeah, you could have two solutions. But it doesn't have to be two solutions. It could be no solution or it could be one solution. Okay, so let's see what happens here. This one, I would take that second equation, solve that for y probably, because I think it's the easier one, which means move that x over the other side, makes it positive, minus 2. And now I can rewrite that second equation with negative x squared plus 2y squared equals 8. And I can replace the y with the x minus 2. Now here, order of operations is going to come into play because my y becomes x minus 2, I still have to square that. What I mean is we can't multiply or distribute that 2 here. We have to take care of that exponent first. Now, if you have to FOIL it out, but you should be able to turn that x minus 2 into x squared minus 4x plus 4. So after we FOIL that out, we get to here. Now we can distribute the 2 and get 2x squared minus 8x plus 8 equals 8. Those 8s are just going to cancel, leaving me with negative x squared plus 2x, scratch that. I've got negative x squared, a positive 2x squared, which makes positive 1x squared, minus 8x equals 0. I can factor that by pulling out an x, giving me x minus 8 equals 0, which tells me x is going to equal 0. And if I set that equal to 0, I get x is equal to 8. Now, what that means is I have one solution at least with the x value that's equal to 0, and I have a solution where the y values, or the x value is equal to 8. And then how do I solve these? I'd plug them right back in here. 0 minus 2 would be -2, and 8 minus 2 would be 6. So there'd be my two solutions. And again, I could use my graphing calculator to check my answer. Okay, so that's the substitution method. I highly recommend the substitution method anytime you are dealing with one conic section and a line. I think that substitution method is the best method to go there. But what if you're dealing with two conic sections here? So in this case, we're dealing with a hyperbola, because it's x squared minus y squared, and a circle. Now, that could have up to 4 solutions if you draw out the different combinations. Now, there's a couple different methods here. We could go with substitution, but we also could use elimination. The elimination method works exactly like the elimination method back with lines. I like it for this one because we have a positive y squared and a negative y squared. If I just simply add those two equations together, my y squareds are going to cancel. So I've got 6x squared plus x squared is going to give me 7x squared. That gives me the y squareds go away. I get minus 28 is equal to 0. And I can just solve that from there. Move the 28 to the other side, divide by 7. And then that tells me x is going to equal plus or minus 2. Now, I knew before I started, I do have the potential of up to 4 solutions. Because I have the possibility of up to 4 solutions, what I'm actually going to do is I'm going to say, I know I have at least one answer where the x value is 2. I might have a second answer when the x value is 2. And then I have at least one answer where the x value is -2. I could have a second one. I don't know if I'm going to need that yet, but I know I have that possibility. Okay, so these are the 4 possible answers here. Now I got to substitute this back in. Now, substitution method or any method, once you find the x, you pick an equation. I'm just going to go with that second equation, the x squared plus y squared minus 13 is equal to 0. So if I plug in a 2, 2 squared is 4. Y squared minus 13 is equal to 0. Combine like terms, and I get y squared minus 9 is equal to 0, which means y squared is equal to 9, which means y is going to equal plus and minus 3. So when I plugged into 2, I got a 3, and I got a -3. Now I still have to plug in the -2. When I plug in the -2, I'm going to get the exact same answer, right? So that's still going to be +4. It would all be exactly the same. So again, I get those same answers. So these are the 4 answers I'd be looking for. Now in this particular case, what I could do is I could do a shortcut version and just write plus and minus 2, plus and minus 3. This answer means 4 different answers. You can only use that notation if you want all 4 of these answers, because it basically means I could have a +2 with either positive or -3, and I could have a -2 with both. If you don't actually want all 4 answers, you cannot use that notation. To explain that a little bit different, if that means all 4, if I write 2 plus and minus 3, that would actually just mean 2 solutions, because that would be the same thing as 2, 3, and 2, -3. If I write plus and minus 2, 3, well, that would be 2, 3, and -2, 3. So again, only the 2 solutions. So that's just the notation. If you want those answers, so in this case, I did have all 4 answers. So if I wanted to, I could use that shortcut notation as my answer, okay? But I couldn't do that with, let's say the last one I did, this one with the 4 and the -4 here, even though, they're all 4s, I got a positive and a negative. If these are the only two answers I actually want, I can't use the plus and minus notation because it would be other answers that actually don't work, okay? All right, so let's try one more. So let's try this one here. Oh, and by the way, before I do that one, I also could have, if I wanted to, I lost my paper. There it is. I also could have, if I wanted to, I could have used the substitution method. I could have solved, so let me show you how that would work. So if I have those same two equations, 6x squared minus y squared minus 15 is equal to 0. X squared plus y squared minus 13 is equal to 0. So if this was my system, what I could have done is say, take that second equation and solved it for, let's say, y squared, okay? So it would be y squared is equal to negative x squared plus 13. And then I could substitute that into that first equation. I can stop when I get to y squared because I'm substituting straight for that. Y squared is so basically I end up with 6x squared minus, I'd have to remember to distribute that negative. But if you do that, you'll end up getting the same thing where you have 7x squared minus 28 is equal to 0, and then the rest is exactly the same. So the substitution method does work there as well. Okay? So let's try one more. This one, first thing you want to do is you want to line stuff up. So notice I don't have x squareds and y squareds above each other kind of thing. So first thing I would do is just rewrite it as, I got x squareds. I'm going to leave a blank because I don't have any single x's. I want to be able to have a spot where I can put that above it. I'm going to put my 2y squared over here, just kind of space that out a little bit. And then my equal signs have to line up. My 4, I'm going to put underneath the 10. My x, I'm going to put over here, right underneath that blank. The 4y squared, I'm going to put underneath there, okay? Now, I have to get these to eliminate. So next step is I need to get those to match up. So what I would do is multiply everything in that equation by a -2. I do the negative because I like to add instead of subtract. So when I distribute that -2 through there, I get -2x squared. And I'd probably leave a little blank just so I don't have to worry about that x in the second equation. That part's not that big of a deal if you can handle just adding the equations. Plus 20, 0 times anything is still 0. The second equation I can leave alone. We have that positive x. We have the 4y squared. We have the 4 equals 0. And now I can just add those two equations. I get -2x squared. I've got that single x. The y squareds cancel, exactly the idea. The key to the elimination method, though, is you really want to eliminate a variable when you can, when you do that addition step right there. Now you just solve that system of equations. This one we're going to want to factor. I, again, never like to factor with an a value that's negative, so I would times everything by a -1 just to make that positive 2x squared minus x minus 12. Factor or quadratic formula. I know some of you guys don't like to do the factoring method. If you want to use the quadratic formula, it will work. I know this is going to be 2x and x. That's the only possible combination with the 2. Let's see. We have to subtract, end up with a 1. I could go 2 and 6, but that's not going to work. I'm going to guess 4 and 3. That would give me 6 and 4. No, let's try those backward. Let's try 3 and 4 here. That would give me 3 and 8. Nope, that's not going to work. Maybe this doesn't factor. Okay, well, worst case scenario, quadratic formula. So negative b, which would be positive 1, plus and minus the square root b squared, which would be 1, minus 4a, which would be 2, c, which would be negative 12, all over 2a, which gives me 1 plus and minus the square root of 8 times 12 is 96, plus 1 is 97 over 4. So it's pretty yucky. Okay? And those are my two ugly X answers. Okay? Okay, so now we got to plug them into for the Y. So, or into one of the two equations. I personally would plug it into the second one, so I don't have to worry about squaring them. And I would go 4y squared plus maybe the positive version here, plus 4. Now, I have a sneaky suspicion that when I move that to the other side, well, it's not really a sneaky suspicion. I have 4y squared. I know that's going to become a negative 4. This is definitely a positive number. And when I move that over to the other side, I don't know what this ugly number is per se as far as a decimal. I could figure it out, but I know that total is going to be a negative. And when I divide by 4, it's still going to be a negative. And then I'm going to end up with y squared equaling a negative number, which I know does not work. So that one actually doesn't give me an answer. Now, when I do the negative version there, well, I have a chance of that being, I know this is a negative number. And I got that plus 4. Now, I do need to know, I know this is going to be a negative number. And when I add 4, I don't know if that total is going to be positive or negative. If it's positive, the total of that, when I move it to the other side, it's going to be negative, and I'm going to get right back to that same situation. So what I'm going to do is at this point, grab my calculator, and just to figure out what that number is as a decimal, to give me an idea if this is possible. 1 minus the square root of 97. Get that answer, divide that answer by 4, and I've got negative 2. Well, that tells me I've got, this is like negative 2.2 plus 4. That's going to be a positive 1.8-ish. And then when I move that over, it's a negative, and I'm in the same boat. So this one actually has no solution at all. That was a lot of work to figure out that that problem had no solution. But it is what it is. You know, that's sometimes that happens. And the only way we could have probably figured that out maybe a little bit faster is using the graphing calculator to solve for y, do something like that. Okay? So again, try a couple of those out of the book, see how it goes. Take it, if you do anything, take a picture of you doing a couple problems, send them to me. I'll look them over and let you know how we're doing. So that's the rest of this chapter. We will see as far as when we get back. I still do plan on reteaching all of that to you guys. Some of you guys will be ahead of the game. Some of you guys, I can tell by the number of views that I'm getting on these videos that you won't be ahead of the game kind of thing. I'm getting about a dozen views each, so I'm a little disappointed in that part. But please watch these and, you know, stay active kind of thing. I know we're stuck indoors, stick at home at least, but stay busy, okay? I will see you guys soon, hopefully. Talk to you later.